Continuing our discussion about water and other solutions, we're still on the solutions part. The water comes at the end. We also want to look at solution concentration. Now, this part does have some math, so grab your calculators and I'll see you on the next slide. Now, we don't always completely saturate a solution. Sometimes we don't want to put just as much solute as possible in a solution, but we do need a way to report how much solute there is. So here we have a couple of different ways to look at that idea of concentration. The first is molarity. Molarity is one that we use all the time in chemistry. And we label the units with a big M, and that stands for moles of solute over liters of solution. Moles of solute over liters of solution. You're going to be using this equation a ton. So let's actually look at this equation. I lost my pen. Let me see if I can find it. Here we go. So here's our basic equation. Big M is moles over volume. Now this is, like I said, one of the equations we will be using, and you might have to rearrange this equation. So let's look to see how else we could, or what other variables we could solve for. You could actually solve for moles. We do that a lot when we're trying to make up a solution and we're trying to figure out how many grams to use. So that would equal molarity times volume. And here, this volume has to be in liters because that's the definition. And then finally, you could rearrange solve for volume. That's going to be moles divided by molarity. So a couple different ways we can look at this particular equation. So that's one way, and that, like I said, that's an extremely common way that we're going to look at concentration in chemistry. But it's not the only way. Now, percent composition is another way, and you'll see this more in everyday life. This talks about the amount of the solute over the amount of solution. But there's actually different ways that we can represent this, different ways that we can measure the solute and the solution. We can have it based on weight, on grams, or we could have it based on volume, on milliliters or liters. So I have on here, there's just some common examples. The first is weight. So what they do is, as they're mixing up the solution, they weigh out their solute, they weigh out their solvent or the total solution, and then they mix it all together. But everything's based on grams. An example of that's vinegar down at the bottom. Vinegar is usually about 5% weight, and weight does tend to be the most common. So that just means there's 5 grams of acetic acid for every 100 grams of vinegar. The second one is volume. So on this one, they just measure volumes whenever they're mixing things up. So this deals with rubbing alcohol. So when you go buy rubbing alcohol or isopropyl alcohol, it's usually a 70 or a 91%, I believe. And so that tells you the volume-wise how much is that rubbing alcohol compared to the entire solution. The last one up there is a weight volume. This is talking about a saline solution, and saline solution is just a dilute sodium chloride in water solution. So what they do is they measure out the sodium chloride on a scale, so that's the weight, that's the grams, and then they have the water and the solution they measure out as the volume, which works out really good because, especially since the density of water is 1, it just makes everything easy. So a couple of different examples. Now comes the fun part. We get to do some math. Yay! So on this, pause as you need to. So the first problem says how many moles of ammonia, so we're trying to figure out how many moles are there in 1.2 liters, so that's my volume, of a 0.5 molar, that's my big M, ammonia. So this is based on that definition of molarity that we saw in the previous slide. Again, pause as you need to as we work through this problem. So the basic equation, molarity equals moles over volume. Now for this equation, this problem, I need to solve for moles. That's going to be molarity times volume. In this case, that's 0.5 big M times 1.2 liters. And then we grab our handy dandy calculator. Let me grab mine out of the drawer. I would say 0.5 times 1.2 is going to give us 0.6. 0.6. Now units on this one are going to be moles. Again, I'm not too concerned about sig figs. If you were looking at sig figs, this would be 0.60. I'll even go ahead and add that in there, 0.60 moles. Now, if you look at the units, just to make sure everything works right, molarity, that big M, is moles per liter, and we're multiplying that by liters. That causes the liters to cancel, and it's going to leave us with moles. Let's try another problem. This one says how many moles, so big question mark, how many moles are in 2.8 liters, so that's going to be my volume. I know I'm bad. Sometimes I use VOL for volume, sometimes just V, of a 0.75 molar or molarity HCl solution. Oh, now this one's really similar to the one right above it. Big M is moles over volume. In this case, I'm solving for moles. That's molarity times volume, or 0.75 big M, remember that's moles per liter, times 2.8 liters. I'm pretty sure that's 2.1 moles. Oops, there's a decimal right there. So this gives you a couple of examples on how to solve for molarity, or to be able to rearrange that equation. You might have to solve for any part, so be familiar with this problem. We've got a couple more on the next slide. Right, so here's a couple of more problems. The first one says, what is the molarity, so what is big M, of a solution composed of 3 moles, so here's my moles, in 1.5 liters, there's my volume of solution. So basic equation, molarity equals moles over volume. Now for this particular problem, I'm actually trying to solve for molarity, meaning I don't have to rearrange my problem. I can just leave it like it is. That makes my life pretty simple here. So I have 3 moles divided by 1.5 liters. That should give me 2. Now for units, you could say moles over liters, or you could just put big M. There we go. Now this last problem, I'm trying to be a little bit tricky. I added a few things in here to, well, let's just say make you think just a little bit. So it says, what is the molarity? So again, we're trying to find out big M of a solution of 2 grams. Now on this one, I didn't give you moles, I gave you grams, but you can figure that out. Of sodium hydroxide in 500 milliliters solution. Oh, there's another change that we have to do. I gave this to you in milliliters, and the definition of molarity calls for liters. So 2 conversions that we have to do, 2 little side reactions before we can actually get started. So let me first convert that 2 grams to moles. Well, to be able to do that conversion, well, I've got to first find my molar mass. So that's whenever you go off to the side, you say I have 1 sodium, that's 1 times, and then you go to the periodic table and find out that its mass is 23.0. Remember, I like to go out 1 decimal. On this example, all those decimals tend to be 0. They won't always be 0 though. I also have an oxygen, that's 1 times 16, and hydrogen, that's 1 times 1. And then I get to add everything up. Let's see here, carry the 1, that's 40. This means that we have 40 grams in 1 mole of sodium hydroxide. Now I'm going to use that so I can go ahead and convert that to grams. Or I have 2 grams sodium hydroxide, and I can say that there are 40 grams. Now I put the 40 grams on bottom so it will cancel, in 1 mole of sodium hydroxide. And because it's on bottom, I'm going to divide. 2 divided by 40, or 2 times 1 divided by 40. It's going to give you that same answer. This means I have 0.05 moles of sodium hydroxide. Now the other thing, again, I was trying to be tricky. I told you that you have 500 milliliters, but you can't use milliliters. You have to change it to liters. Now I'm going to set this up like a unit conversion because when I was younger, and still today, I got confused. Which way do you move the decimal? And I found if I set it up like a unit conversion, I can always do this right. But you have to remember what's equal to what. I know that there's 1,000 milliliters in 1 liter. Now notice my milliliters on bottom so that my mils will cancel. This is going to give me 0.5 liters. Okay, now I have all the parts, and I can go ahead and plug it into the equation and solve for my answer. Basic equation, molarity is moles over volume. So that's going to be 0.05 moles divided by 0.5 liters. Okay, let me get my calculator, make sure I do this one right. Yep. And that's going to give me 0.1 big M molar. All right, so that was a few examples of how to find molarity. This would be a good thing to be sure to look at for the test. Now, one of the places that we're concerned about the concentration of solutes is actually in your blood. Now, your body wants what's called homeostasis, which means everything is where it's supposed to be. So your body maintains temperature and also blood composition within certain limits. But if we go outside those limits, either too high or too low, you will start seeing some issues. So some different things that we can look at blood sugar or the glucose in your blood. So if you have too much where your body can't regulate that glucose, you can become diabetic. But it also is a problem if you have too little, and that means that you're hypoglycemic. Electrolytes. Now we actually started the entire semester talking about infant formula and how there was these babies where they'd accidentally switch the sugar and the salt, and so they gave the babies salt in their formula instead of sugar, and it threw out their electrolytic balance. So that was too many electrolytes. You can also have too few, such as marathon runners after a race. They will sometimes almost look like they're drunk because they have too few electrolytes, or they're water intoxicated. Enzymes. So back just a couple of chapters, we started talking about enzymes. Maybe some of you are lactose intolerant, meaning that you have a problem breaking down dairy products because you're missing that enzyme lactase. That's one example. Triglycerides and cholesterol. Remember, cholesterol likes to accumulate on artery walls, so if you have too high, that becomes a great concern. And finally, hormones. Hormones is an area that I don't think is actually talked about enough in your everyday life. Hormones can really affect you, so please be careful. Something as simple as, or not as simple, something like birth control pills actually changes your hormones. So just be very wary and learn as much as you can before you start messing with your body's chemistry. So those are a few things that we look at the concentrations. So what if those concentrations are really, really small, where a percent composition or even molarity is just not enough? We need something in a smaller amount. Well, we can do smaller concentrations. Now these are looking at a percent composition, just instead of how many grams out of 100 grams, we're looking at something much, much smaller. For example, parts per thousand. Now you do have to be careful because sometimes PPT, depending on the industry, can mean parts per trillion. So just beware. We're going to talk about parts per thousand, which is 1 part to 1,000 parts solvent. So this is like a 0.1%. Now this one works out really good math-wise because it's a gram in a liter of water. So 1 gram of solute in a liter of water. If we go smaller, we could talk about parts per million. This one I'd be pretty familiar with. This is going to be your milligrams per kilogram, or 1 part solute for a 1,000,000 part solvent. So how many milligrams do you have in a kilogram or a liter of water? Now to help represent that, we have this thing. This is a Becker bottle. And so if you look at it, there's a whole bunch of yellow beads. Somewhere in here, there is one little black bead, and it looks like I'm not going to be lucky enough today to find it. I'll have students spend like all semester picking this up to try to find it, and other times you pick it up and it's right on top. You never know. But this is to represent 1 part per million. So if you can find the little black bead, 1 part per million. That's not very much, but we're going to see that as we start looking at certain contaminants, we do measure parts per million, milligrams per kilogram. We'll also deal with that when we start talking about toxicity in a few chapters. The last one is if you want something even more dilute, this is parts per billion, 1 part solute in a billion parts solvent. So that's a little bit about how we can measure concentrations.